Hello there, my little math geniuses. In fact, you aren't that little, but you're still math geniuses. I almost said you're not even math geniuses, but I know you guys are brilliant at math. I marked your tests, and it was quite clear that you are little geniuses. Actually, big geniuses. Okay, so what are we doing today? Decimals greater than 1. What is this weird word? Decimals. Okay, we'll take a look. How can I teach you this? Okay, so let's first remember something. So what were we dealing with here? Well, we remember that apparently it wants me to start off with reviewing how we write a decimal from a fraction. Now, it's like we haven't been doing this every single day, but you know, anyways, review makes certain. How do we write this as a decimal? And we have to remember that tenths are 1 digit to the right of the decimal point, and hundredths are 2 decimal points to the right. So let's do 2 ones to make us fresh and ready to go. So let's do this. So if this one is a tenth, what are we going to start with? Well, we're going to first start off with a 0 and our precious little decimal point, right? Okay, and then what? After that, we'll just say 6, right? Because it's a tenth, it's a tenth, so we just stick it into the 10th column here, and we are all done. And now this one, it's the 100th, so we have to remember that that instantly tells us that there are going to be, it's going to be 0, dot, and then there will be 2 blanks, right? 2 places for us to put numbers. And so out of 100, we have 34 hundredths. And as I was talking about yesterday for you guys, that this would be 3 tenths in a sense, and 4 hundredths put together, and that makes us have that place, and that's why they go into those distinct spots. Now, what we're going to do today might boggle your mind, so get ready, buckle up, grab your popcorn and your chewing gums or whatever you have. No chewing gums, we're still in school, right? But okay, so let's take a look here. Remember these things with 2 in front, and then maybe like a 3, let's say 3 tenths. What is this crazy thing called here? Well, this we know as a mixed number, right? That's a mixed number because there's a number and a fraction. So how can we turn this into decimal? Well, so happy you asked. We can do it like this. This would be what it is. It's 2 point, oh, I did it again, 3. Now, how do I know this? And why is there not a 0 in front of here anymore? Well, my young learners, that's because this, if we remember, represents wholes. And this remembers a part. Or this represents a part, doesn't remember a part. And it's the same here. When things on this side of the decimal are representing whole numbers, and things on this side represent portions of a number. And so that's why we take the 2 over here and we plop it right here as a whole number. There's 2 wholes and there's 3 tenths of another whole here. So I hope you generally understand that. Now the same thing, yes, so the whole part of the number goes to the left of the decimal point, and the fraction part goes to the right of the decimal point. So if I were to do another one, this one's a big one, 13, and I said 74 hundredths, what would this look like as a decimal point? Well, first we can just instantly say, okay, well, these are wholes, right? And I just like, okay, well, let's put that one here. That'll be 13 point, and then we have to think about this. Well, this is out of 100, so we'll know how many spaces will we need. Well, we'll know we need 2 spaces, and it'll be 74. So it'll be 13.74. Perfect, beautiful. So this means the same thing as this. These are equal. They're the same. They're representing the same thing in two different ways. So yeah, and to do the opposite is quite the same idea, right? So if I had, for example, 3, 1, 4. This is actually a cool number, and I'm sure that some geek wrote this down particularly. We won't get into that just yet. But how would I make this into a mixed number? So this is going the other way. Well, I'm happy you guys are so interested. So here we go. We say, well, what's the whole number here? Well, this is the whole number right here. This is a whole number. Whole number. Perfect. So we know, and we just put it in the whole number spot of a mixed number. So we just say 3, and then we have to figure out what the fraction is. Well, when we look at this, do you think it's going to be out of tenths or hundredths? Well, because there are 2 digits instead of just 1, we are going to say that it's out of hundredths, right? So we just, oh, why does that happen? Nobody knows. Actually, I know because I keep touching the button. Oh man, I didn't think the button is, oh, it's so sensitive. Oh man, sad. Okay. Oh wait, and I don't even need to make a dot. That's the worst part. So yeah, it's out of 100, and it's like that, and there we go. Silly Russian. Why are you thinking like that? You can't even do it properly. Okay, so you get that it is out of 100 because there are 2 numbers here. Now, if I had a different one, let's say, for example, 7 point, oh, actually, let's do 17.6. How do we do this one? Converting it into a mixed number. Well, this is our whole section. Remember, anything to the left of the decimal is a whole number, so we make it wholes. These are our wholes. So we'll have 17 wholes, and how many fractions? Well, what's our fraction going to be? Well, is this going to be a tenth or 100? Well, let's take a look here. When there's 1 digit in the back here on the right side of the decimal, that means this is a tenth. And so we'll simply say that there are 6 tenths, and that is how easy that is. Now, there is an important point to be made here. Very, very important. That we are not mixing this up. We need to be able to write these out. So, if I give you something like this, I'll just scroll down a little bit. Okay, so say we had 3 and 0.17. How would we write this out regularly? Well, we would write this out not by saying 3.17. We actually say this: 3 and 17 hundredths. So that's how we say it. We say 3 and 17 hundredths. So remember that. And this and is quite important. We need to remember this and. This, when we say and in here, and this is why you need to be paying attention, because perhaps you'll get some word problems that'll say blah blah blah, he had 3 and 17 hundredths. And you have to think, when you see this and we're dealing with decimals, this and means the period or the decimal point, and the 17 hundredths means the things behind the decimal point. And of course the 3 is just a regular old 3, nothing too special about him other than he's friends with all these decimals and stuff. But yes, so that's something you have to remember. And we could just show you again just a few more, like what we had here. I guess instead I can just say, okay, so what would this be? Well, you'd say this would be 17 and 6 tenths, right? Just as simple as that. And then you know that this period is that, and this is in the tenths, right? Because it's in the first section, so we say that it is tenths. There's not two numbers. If there's two numbers, then we'll talk about them as hundredths. So I hope that we get that. Now we're going to move on. I'm going to have to make a new little page here. We'll just go over here, and now we'll be dealing with these things that I know you probably didn't want to see again, but they never give you a break. Improper, what am I going to write here? F fractions. Okay, improper fractions into decimals is our ultimate aim here. But first we have to remember, how do you turn an improper fraction into a decimal? Well, let's just take a regular old one, 7/3, right? What would this be? Well, this will equal ultimately 2 1/3. Now, how do I do that? I do it like this. I say 7 divided by 3 is equal to 2 remainder 1, and because we're dealing in thirds, I know that this remainder 1 is 1/3 left. And that is how we get that. Now, this one itself, this example would not be as easy to convert, but let's show another one. Let's do 24 tenths, because we love our tenths. What will this equal? Well, this will be 2 4 tenths. And how would we write that in decimals? Well, we've already done a lot of this. We would say that this is 2 4, right? It would be 2.4, because the 2 goes in. I just switched into an American accent. Don't know what happened to the Russian guy, but he's left. No, he's never left. I'm back. Sorry, I just messed up my accent for a second there. But yeah, the 2 goes here. It's the whole number, and the fourths go here, or the tenths rather go there, because it's in tenths, so it's just in the first section, correct? And that's how we figure this out. Now we've just shown how to actually change a decimal or an improper fraction into a decimal by doing 2 steps. We can go here to a mixed number and into a decimal system number. So that is interesting, but you know, I'm gonna do a few more, and then I'll see if you guys start to see something interesting with the pattern that's starting to show up. So let's take a big one, a big monster. 382 over 100. Well, what would we do here? Well, we'd say 382 divided by 100, and that would leave us with a total of 382 and 100. So 3 wholes and 82 hundredths. So that's quite helpful for us for figuring out the next part, right? Because then we can easily say, okay, we've learned how to do this. It's hundredths, so there's 3 wholes, and we know that there would be a period there, or a decimal point, so it would be 3 and 82 hundredths. Perfect. So that's interesting. We've done it again. Now let's do one more over here, and actually no, let's do one more underneath, because I'll use over there for showing you what's going on here at the end. So let's do 28 over 10, and we'd say, you know, just do our math here. 28 divided by 10, and that's going to be 2 remainder 8, and that actually turns out to be, in our mixed number, that'll be 2 wholes and 8 tenths, and then we can turn this into our decimal. We can go 2 and 8 tenths, right? And then we do one more for just for the fun of it, 154 and 100, so 154 hundredths, and also we know this one is 154 divided by 100 equals 1, and it ultimately will be 54 over 100. So 1 in 54 hundredths, which we know converts into a nice 1, and we know it'll have 2 digits behind the decimal point, which will be 54. So it'll be 1 and 54 hundredths. Now, I want you to look at something here. If we have 382 over 100 ends up being 3 and 82 hundredths, and you'll have 28 over 10 is 2 and 8 tenths, and then you have 154 over 100, and that is 1 and 54 100ths. Do you start to see something? I think you might be noticing something that I noticed, and I'll just do one more just to make this clear, that something is going on here that is kind of a pattern. So what is this one? I can actually do this without even looking. So there is something happening here. I'm not entirely sure what's happening, but we're seeing some similarities. Okay, I won't hold back from you anymore. When we're dealing with these improper fractions, there's actually a shortcut to finding the decimal version. And really, what you can notice here is that when it's out of 100, the decimal, there's 2 numbers that'll go behind the point, right? 2 numbers that'll go behind the point. And well, first, just in case you haven't noticed, these numbers, the only difference is the decimal point. And really, when they're out of 100, you'll notice that every time 2 of the numbers goes behind the decimal point, right? You just kind of take the dot and go 2 over, and that helps you find it. And with 10, if it's over 10, you'll go over just 1 and make the decimal point there. And that's a shortcut for finding it, right? That a decimal, when you have 2.8 over 10, you can just move the decimal point over. Now, I don't want to confuse you or anything, but this works when you divide things. So if you said 382 and you divide it by 100, that really, yeah, it does actually. If you do this on your calculator, it should bring out exactly that. And that's kind of what's happening here, that the decimal point moves over twice, because, yeah, and it kind of moves over, you could almost think of it moves over for every 0 in the 100 or in the 10, right? So that is just a kind of a cool thing. So if there's a denominator of 10, means that it'll be 1 digit after the decimal, and a denominator of 100 means there will be 2 digits after the decimal. So you can kind of work it like that. So remember that if you see, if you're ever asked for an improper fraction, you can do it like this. That's totally fine. Go for the mixed numbers and then convert it. Or you can do a shortcut where you see, okay, well, it's 100, and that means that this will be, there will be 2 of these digits behind the decimal, and whatever's left will be on this side of the desk to the left. So yeah, I hope that helps you. We'll have one final thing to kind of look at here, and that's just going the other way, I suppose, is what it wants me to do. So if I say, sometimes I lose my little thingy here. Okay, 31408. What would this be in a fraction? How would we turn this into a fraction or an improper fraction? So I can give you this part, and that's the most important part you need. what would we be doing? What would go down here? Well, now let's just take a look so you can see the dot there. What is this say here? What does this say when you see two numbers behind the dot? What does that scream out to you? Hundredths. So when we see the two dots and we want to turn this into a fraction, we will simply put down here 1/100ths. And if you were just given this number and you were told to do it, maybe let's say you were given 21.73 and I wanted you to convert that into hundredths of a fraction, well, you would put 2,173 hundredths, and that would be correct, right? And basically what's happened here is now this period has jumped back 2 spots to be out of the equation, right? Or not a period, decimal point, forgive me. But yeah, so that's important to know. And the same thing would happen if you had, for example, a 5.4 and you wanted to convert it into a fraction. Well, you would know that it's going to be 54, and then we would say this is tenths because there is 1 digit behind the decimal point, right? So then you'd have tenths. Now, I've already talked about what I'm going to mention before. Let's just delete some of this. This is a lot faster than the old whiteboard. I don't know if it's as nice in every measure, but yeah, I've talked about equivalent fractions and hundredths and tenths, and I just want to make it clear again for you, and the book wants me to make it clear to you, so that this, right, we've talked about when you times this by 10 and times that by 10, that equals 70/100ths. So right, 7/10ths is equal to 70/100ths, and the same would be set true, right? If we had 3, 7/10ths would be equal to 3 and 70/100ths. Now in decimals, right, this would be also true, that you would have 0.7 is equal to 0.70. So that's important to remember, and the same thing would be true here. 3.7 is equal to 3.70. And yeah, if you were just to look at any thing like this, so 5.8 is equal to 5.80. So yes, it's basically like saying, you know, this is like saying 5 8/10ths is equal to 5 80/100ths, and you can do the math to figure out that those are equal. Anyways, guys, that's just a little bit of review. I think I've talked about that a lot through our lessons already, because that kind of came up naturally. I hope you've enjoyed the math lesson, and you've been able to understand the switching of the Russian and American accents. It's getting a bit late tonight, so I think my accent system is breaking down. But anyways, guys, I hope you enjoyed the video, and bye for now. Have a good day.